And welcome, students. In today's lecture we will be covering section 2.2 in part. We're going to go over different numbering systems and using different bases. So I'll do this in two parts. I'll do the numbering system in the first video and the working with different bases in the second video, and I'll explain how that the different bases happened. I also want to have you notice what it is like in using a number system that's different than your own, and just as we did in the Venn diagram and set theory videos, those notations might have been unfamiliar to you. Well, that's what you're going to be teaching. You're going to be teaching notations that are unfamiliar. You're going to be teaching students to make sense of symbols and their meaning and using those symbols. And some of your students may have never seen any of these symbols before. In fact, many of your students won't have seen those symbols, and they're going to have to figure out how to make sense of symbols and what they mean in terms of a language. And that's what you're going to be teaching them, just as you kind of muddled around sometimes with the set theory and the Venn diagrams, trying to make sense of the pictures or the graphics, which sometimes we call graphing, or the different symbols that mean union and intersection, which are equivalent to adding and subtracting. And then you'll also combine multiplying and dividing and whatnot. So let's get on with what we're going to do in 2.2. To begin with, a little bit of history in counting just has to do with, just think about how it all might have happened, and notches would have been a very simple way to keep track of different things, whether that be, as they suggest here, how many animals that you killed, or what day might have, how many days might have transpired between summer to winter, or just keeping track of different things using notches. Of course, there was probably no point in using a counting system until you became a little more sedentary, and they've determined that archaeologists said that this happened somewhere between 10 and 12,000 years ago when we started worrying about counting things. Now, as we think about counting things, we can imagine it to be things in a set. We have a set of shapes, we have a set of chairs, we have a set of balls, but within each of those sets would be three items or three elements. And we're talking about things in the abstract, and for some students that's very difficult, so that's why we bring in visuals and manipulatives to try to help those students. Furthering with that abstraction, we count things in terms of a length, and there's nothing really there to count. It's just some sort of abstract quantity that we've come up with, whether that be an inch or a foot or a meter or centimeter, and we're supposed to count how long something is or how tall or an area, and all of those things are fairly abstract whenever we're talking about counting. Now, we counted these things and we had to have some symbol for our each number, if you will, and there are many different ways that this developed. We didn't have the internet to kind of get a congruent system, so everyone had their own way of doing things. And we'll explore a few of those different numeration systems. First up is the Egyptian system, and the reason when you look at these symbols you'll realize why they were able to draw elaborate systems is because they had paper, and so we'll look at their numbering system. Now, these are very beautiful to me. They're little beautiful symbols. A tick mark or staff meant 1, and every time you see one of these heel bones, that means 10 of those. Every time you see a scroll, that means 100 of those, and so forth. And they're more elaborate symbols because they were able to draw. This is known as an additive system because you just look at the picture, and on the lotus flower, which is what we see first, we notice there's 2 of them, so that would be 2,000. There's 3 of these scrolls, that would be 300, 100 plus 100 plus 100, or you're just adding these up. 1 heel bone, and 2 staff, and you just add this up and you get 2310 as what, oops, 2312, sorry. So what you'll get in powers of 10 or in base 10 system that we typically use. So let me write my 2 so that I can add in there. Okay, so beautiful. So you'll notice the Egyptians and how they use this additive system to create all of their different numbers, and they used powers of 10 basically, just as we do now. We use some form of that as well. So you'll have a homework question. It'll look something like this, and what you will do for this one is you will find your lotus flowers, which is worth 1,000, so that is 2,000. There are 2 heel bones, so that would be 2,000. 2 heel bones is 20, and then 1, add them up, and you will put 2021 in this slot. For your polywogs, which is in the B part, we need 3 of those polywogs worth 100,000 each, so that's 300,000, and then we need 2 pointing fingers worth 10,000 each, and then there's my pointing fingers, 2 heel bones worth 20, and then 2 staffs worth 2. Add that up and place it in the box. All right, on to the next one. The next system we'll look at would be the Roman system, and here's our table of what the Romans used. It's another form of an additive system, but in this case they had a symbol for a halfway mark, because sometimes writing 8 of those astonished people or 8 lotus flowers and 8 pointing fingers, that stuff got kind of long, so they decided to do a halfway mark for the Romans. They kind of advanced the system a little bit. And this is also a little discussion about the Romans, talking about it being an additive system. And then later on, the Romans also introduced a subtractive element to their system, but they didn't do that at first. At first it was purely additive. And what they did to introduce the subtractive element was that if you have a symbol that is less than the one that comes after it, you are to automatically know that you should subtract. So here I have a symbol for a 1 and a symbol for a 5. Since the 1 comes first, you would say, well, that's 5 minus 1, so that would be 4. Right, here we have an additive system. This is our Roman system. I'm going to look to see if anything, because I'm not familiar with the Roman system, I need to look and see if there's anything less than that comes first, or if this goes in order. So it goes M, D, C, C, that's all good, then L, then X, X. Oops, here's where I'm going to have a subtractive element. So I can automatically look at that 1 and that 10 and go, okay, well that's going to be 10 minus 1. So this symbol here, this IX, represents a 9. So let's go ahead and do our addition. M means 1,000. D represents 500. C is 100, but there's 2 of them, so I'm going to write 200. L is a 50. 2 X's is a 20. And then I have a 9. And then I will add all of these up. The next one is purely additive, so it will be another 1,000. A C is 100. A D, oh no it wasn't, because it went C then D, so I need to get that off of there. I didn't check it closely enough, so here we go. That CD means 100 minus the 500, so this little guy right here represents 400. So I've got 1,000, I've got a 400, then I've got 3 X's, that is 30, and then 5 and 3 are 8, and I would add those up. And that's how you'll do your homework, just a little practice with doing those different systems. And it's just to help you realize what it might be like to try to make sense of symbols and base systems, and taking this abstract concept and making sense of it. The next system will be the Babylonian system, When you look at the Babylonian system's symbols, you'll think about the fact that they didn't have paper, but they had clay, and their symbols reflect the materials that they had to work with. So you can notice that this is their symbols, and they would just press a mark into the clay and make these wedge shapes. They were only able to make 2 symbols, and because of this it was extremely difficult because they couldn't make a lot of symbols. They couldn't draw anything fancy. So what they did instead was they created a new place. So we'll see how they used these 2 symbols to create all kinds of different numbers. They chose 60 to be their new place value, and if you'll notice this single, which is supposed to represent a 1, when it's written to the left it represents a 60. So if you had 60 plus that 10 would be 70, and then add the singles if it comes afterwards. So this represented the number 73 without having to make 7 of these kind of C-shaped wedges. Using this technique, they could represent rather large numbers. Each of these single marks represents a 60 because it's to the left of this wedge. So that would be 6 of these 60s plus a 10 plus 2. And 6 of these 60s, it would be 360, 370, 1, 2. And we call this a positional system because it depends on where the mark is made, and we use that system as well because it depends, as our 0 is a position holder for us in a lot of cases. So let's look at what they did with this crazy number, because we now have, not only do we have these singles to the left of our C shapes, but we also have things to the right. So let's break that one down and figure out what they're talking about. You would look at this number in 3 chunks, really. You would look at it as this chunk, and this chunk. And our very first chunk is typical. It represents the number 21. So we're good with that. This next chunk, because it's to the left, we know it's powers of 60, or it's values of 60. So not powers of 60, but we will be in just a second. So there are 23 of these 60s. So this represents 23 60s. And this 2 shaft here represents the power of 60, and it means 2 of these, so I'll do it this way, 2 of these 60s squared, and you would just add all of these numbers up and you would get this big old whopping number. So much more complicated here, but look at them in chunks, and that helps a ton. So this is a somewhat more sophisticated way to represent numbers, a little tougher way in order to understand, which really our system involves something similar, but it's powers of 10. So it is a little bit harder to understand, and the fact that there are place values there. And this particular system also has a few glitches to it, though, because sometimes numbers are the same set of symbols represents a couple of different numbers, and they give you that information here and how it can look like 2 different numbers, the same set of symbols. So what they did instead was try to do some sort of sideways symbol in order to designate the fact that there was a placeholder there, or there was a 0 set there. So for your homework, you'll need to do some of these. So of course they give us, let's do this G one first because it's just plain adding here. I see here's a chunk and here's a chunk. So I would get that number is 13 plus this is 260, so that'd be 120. So this number would be 133. So that one's done. Now this one is a little tougher because it has this placeholder here. So let's look at it in chunks. I have 3 chunks where my second set here, so there are no 60s in this one. This would be 2, and this represents the fact that there are 21 60s squared. Now if you multiply that out, which I already did, is 75600 plus none of those 60s plus 2, so this answer would be 75602. Not quite as easy as just the straight adding one, a little more intricate. And our very last new system that we're going to look at would be the Mayan system, and what the Mayans did to develop their system. Now they had a very complex system with a 0. Notice there was no real 0 with any of our other systems. This system was rather handy. They were able to write their numbers vertically, the system that they came up with, and they had symbols for 1 through 20. Now to make it just a little more complex, what they didn't do just plain old base 20 or just a plain 20 system. What they did was their first 5 places represented first a 1, then a 20, 3, 60, 7,200, and 1440. So 14,400. So let's see what they do with that. Alright, let's see how to work in the Mayan system. Now, this first place value is in the ones place, and I have a line and a dot. So that would be a 6. This second set of numbers is how many 20s you have. So there are 4 20s. So this would be equal to 80. Add it with my 6, and this answer is 86. Alright, so they want me to take the number 241 and put it into Mayan. So I look at this number as 240 and a 1. So my first thing is I would go look for a 1, and he's just a dot. For my next thing, could I make this in in multiples of 20? And I can. This would be equal to 12 times 20, and their second place was multiples of 20. So that would be 12 of those. So I need to next write 12, and that would be 2 bars and 2 dots. And that is this guy right here. So remember, in the Mayan system, the very first one is your multiples of 1, or your representation in the ones place. The second one would be your multiples of 20. And lastly, we have the Hindu Arabic system, which is based off of what we're doing on our number systems. You can notice as the numbers kind of derive themselves. By the 16th century, they look just like our numbers now. So this is the Hindu Arabic system. This system, of course, has transformed over the years, and now it looks like what we have now. So that concludes our lesson on the different numeration systems. The next video I'm going to start with will be talking about working with numbers in different bases. So let me know if you have any problems. Just email me, and have a great day.